Okay, so what I'm going to go through in these series of videos is a tutorial of all the steps you need to do to prepare the Globe Mission Earth weather station following the manual, the written manual. So I'll go through each steps and show you how to assemble the whole board, how to prepare each circuit, how to lay it out, and so on. Okay, so we'll start with the basic power management board and work our way through there. Okay, so the first thing that we need to do to help prepare this power station is to prepare the solar panel battery power management board. Okay, so this is purchased from Adafruit, like all the boards we're using here for this project. Okay, and this one is entitled the Solar Lithium Poly Charger version 2, I suppose. Okay, so what comes in this little package? We have three things. We have the board itself, that's over here on the right. We have this large capacitor, and we have this this connection cable that comes with it as well. If we take a look at the board, it has 4 different terminals for connections. We'll only use 3 of them. Okay, this large one over here, this barrel connection, will connect to our solar panel. You can use this small port over here to charge the battery directly, but that's not necessarily a requirement. Okay, so I won't focus on that here for these videos. This port over here, it accepts a connection a terminal just like this one. Okay, this eventually connects to our battery that we're going to use to charge and power us when the sun isn't shining. Okay, and then this port over here is what we'll use to connect with this cable that ships with the package. This passes on the power from this board to the rest of our circuitry. Okay, and there are 3 things we need to work with for this board to prepare it to use for our weather station. So in reverse order, for what I'll show you in these videos, we need to solder in this large capacitor over here. That will solder into these 2 junctions there. Okay, I'll show you how to do that. We need to replace this built-in resistor over here. So this resistor function, as it is incorporated with the rest of the board, helps to manage the charging that goes to the battery. Okay, and with these types of systems, if it gets to be too hot or too cold for the ambient temperature, that can damage the battery. And so this resistor helps to manage the range of temperatures that it charges over, but it's not really appropriate for what we do here. So we need to replace this resistor with an actual temperature measurement, and so I'll show you how we do that. So we'll eventually remove that, and then we're going to supplement this resistor with another resistor to help change the charging rate of the battery to make it a bit more optimal for the solar panel that we're working with. Okay, so those are the 3 things that I'll show you in the next few steps. Okay, so I've taken my resistor. This is that 2.02 kilo ohm resistor, and I've bent the wires so that they will insert nicely into these 2 holes here. Okay, so I'll put those in, and I'll bend them so that they go through the bottom and they lie flat with the board, and then we'll solder those in and trim them. Okay, and next I'll then take the 2 leads from the thermistor. Now, when this ships, these 2 end leads will be more or less connected together. Okay, so each of these black casing components here surrounds the wire which carries the current through. So you just want to take a thin knife and separate those out so they have a little bit of separation, so we can separate them apart to connect them to the leads where they need to go. Okay, and eventually what we'll do is we'll feed those up through the bottom of the board, under here, under that terminal there and that terminal there, and then feed them up through the board so that the actual wires themselves are under the board so they don't stick out over it and get in the way for later on. Okay, so we'll start by inserting the resistor, and we'll solder that up, and then we'll insert the thermistor leads and we'll solder that up as well. Okay, and to show you what it looks like before I solder, I've inserted my resistor here. I've bent the wires out to the sides, so it more or less holds it in place. And then these 2 coming up here, these 2 wires protruding up from the bottom, those are from those thermistor leads. So if I flip it over, you can see what the bottom looks like. There are the resistor wires going out to the sides that I'll solder and trim, and then the thermistor wires going up through the bottom. So we'll solder those next. Okay, and to show you what those look like now that they're in, again, you see the solder joints on the back. Perhaps it's easier to see. You can see the solder joints on the top. Those are from the resistor. I've trimmed those leads off, so those are now gone. Okay, and then I've soldered the bottom as well, and sorry, rather the top. So the solder you can see there and there from the thermistor leads. Okay, the next thing we need to do is to remove the built-in thermistor that comes with it. Okay, so that is this, the built-in resistor that comes with it, and that's this little component here. So take anything that's nice and sharp, okay, and you just want to sever the two connections there, and that will physically remove this little piece, okay. Go ahead and do that. And then the next step that we're going to do is to insert the capacitor. Okay, so capacitors do have polarity, which means that each wire here for this type of capacitor has either a negative or positive connection that needs to be made for it to function properly. And if you look at the board, it shows you which side should be negative and positive. Okay, so negative side is over there on the left, positive is over there on the right. And what's nice about this type of capacitor is that it shows you which is negative. So this is the negative side here. That's always the shorter lead of the two. Okay, so leads of different lengths when you initially get it. So you know which one is positive and negative. So you just want to make sure that when you insert it, that you insert it in the correct order there. Okay, and also when you insert it, you don't want it flush to the board. We don't want this entire capacitor sticking up all the way straight vertically out of the board. Eventually what we want to do is we want to bend it so that it's going to lie flat and away from the rest of the electronics on the board. These capacitors can get hot, so we don't want that heat to affect any of the other components on the board. Okay, and by lying it flat, we can also lower the profile from the whole board, so it'll sit well in our housing eventually once we put everything together. Okay, so I'll show you what that looks like once I insert that. Okay, so I've inserted the capacitor. We have negative on the closest side, where it's supposed to go, positive on the farthest side. Again, it lines up with the symbols that are printed on the board itself. Okay, and you can see that the capacitor, it's not lying flat against the board. You don't want it to get too hot. Okay, but I have tilted it a little bit so that it's not quite as tall as it might be otherwise. We do have to be careful about how high all these boards get once we eventually assemble them. Okay. I've also trimmed, if we turn the board over, I've trimmed the leads that were previously sticking through. Okay, so you should find that the leads are going to stick through the bottom of the board. Trim those off once they're soldered. Okay, and in general, the shorter the lead or the wires that you have in any of your circuitry, the better that your circuit is going to perform for various reasons. Okay, so those have been trimmed off. And then looking at the rest of the board, eventually we will have to connect three other components to the board. Okay, so this big connection over here, this port will go to our solar panel. Okay, you'll see a large round connection from our solar panel that'll go into there. We have these two ports over here, and these are this type of wire here is what's going to plug into there. Okay, so you should find that your battery will have a terminal looks like this. Okay, and that'll eventually go here on the left. Okay, it's printed. If you look at it closely, you should see that it says battery there on the left. All right, and when the battery is plugged in and charged, or if the sun is shining, you have the solar panel going in here. This little charge light, there's some LEDs that will light up here. The charge light should light up over here, so that's a diagnostic that you know. And when the battery is fully charged, then this done light will turn on. Okay, it gives you some feedback there as to what's going on. The other port is over here on the right. Okay, and this is what delivers the power out from this board to the rest of the electronics. So eventually we will connect this connection to our next component, which is something called a buck boost board. Okay, so one of the issues that we have in this overall weather station is that when the sun is shining at its peak, the solar panel is going to develop, for this type of solar panel, it will develop a certain voltage, okay, and that will go to the battery, and that's fine, okay. But as the sun dips down, then the voltage that you get out from the solar panel is going to decrease, right? It's going to vary between 0 and some maximum voltage. Most of our electronics that we're going to need for the rest of our components only need 3 volts. Okay, so when the sun is shining at its peak, it's going to develop more than 3 volts, and that's a problem. So what the buck boost does, or the boost buck, is that it basically manages a certain range of voltage. Okay, so anything between 3 and 12 volts is going to regulate that to give us a certain output of voltage, which is going to be safe for the rest of our electronics. So if the sun is too low or we're not getting quite enough, this will increase that voltage up to what we need. Okay, or if it's too high, it will decrease it. Okay, and again regulate it to our needs down the stream. Okay, so this is going to connect to the rest of our electronics. And as far as preparing this board for the circuit, for the rest of it, with the integration, is fairly straightforward. This board is going to ship without these 2 blue things in here. These are 2 terminals that do ship with it. Okay, so you need to basically just solder those 2 terminals onto it. I'll show you next what it looks like when it ships. Okay, so this is what you get fresh out of the bag from Adafruit. Okay, so it will ship with 1 terminal and then a USB terminal as well. So we'll use the black terminal, not the USB, so don't worry about that one. Okay, but take out the black terminal and you're going to position it one at either end. Okay, so one will go here. Okay, and then we have some extra terminals we've ordered as a separate part to make this all work together. Okay, and you'll position that second one here in those 2 rightmost holes. Okay, and you can see the finished product. So basically it just goes through the holes. You want to make sure that the connections to your wires are facing outwards so you can easily plug them in. Okay, it's a screw down clamp system. So with a Phillips head screw, that's why we need these jewelry screwdrivers. You're going to want to screw down those screws eventually once you connect all the wires. Okay, and at the bottom you can see where I've soldered it. Okay, so solder here on the left for the leftmost terminal, soldered over here on the right for the rightmost terminal, and that's really all you need to do to prepare this board. So it's just 4 solder joints.